Hi, my name is Kasmin Danil, and today I'm going to present my FYP project, which is augmented reality for smart automatic handling system. And my supervisor for this project is IR.DR NOOR AZLINA SALLEH. And for the introductions, what is augmented reality? So the definition is an enhanced versions of the reality created by the use of technology to overlay digital information on an image of something being viewed through device such as smartphone camera. So as we can see here is the brief illustration flow of how the AR work, where the person use the smartphone to detect the marker, and the marker, which is created in Vuforia or processed in Vuforia, will show the object information on smartphone screen, and the smartphone screen is viewed by the users, which is human, us. For the augmented reality SDK, the chosen SDK is Vuforia. This is due to the special features of the Vuforia, which is recognize multiple objects, include boxes, cylinder and toy, as well as image. Support text recognitions, include about 100,000 words, or a custom vocabulary, allow creating 3D geometric map of an environment using a smart terrain feature. Fourth, turn static image into full motion video that can be played directly on a target surface. Fifth is provide Unity plugin, and the last is support both cloud and local storage. So basically, Vuforia is better and have their own special feature compared to the others toolkits. And here is the Unity that's used in creating the application, AR application. So basically, Unity engine is a game developer that for a computer, smartphone, Microsoft, HoloLens, and many platforms, and it is available for free for developer. So this is the example of structure or simple explanations of the AR structure. So for example, the trigger image or tracker plus overlay video will result in published video, and here trigger image or tracker plus overlay 3D model will publish the 3D model. So as for the problem statement, there are errors when storing and using handling machine. Most of the errors occur when handling the machine with less expertise and knowledge, especially done by new user. By implementing the augmented reality with smart automatic handling system, we will assist new users to handle the machine efficiently, thus eliminating the errors and boosting the learning process. So this is the main reason why I want to combine the AR with the smart automatic handling system. So the objective of this study is to study the smart automatic handling system components, functions, operations, and application through guidance of AR technology. Second objective is to simulate the smart automatic handling system layout. Third is to provide standard operating procedure of application of AR in smart automatic handling system. For the research methodology, in terms of methodology, the method used is Six Sigma MEC, which stands for define, measure, analyze, improve, and control. This method is crucial for improvement to existing product, service, and methodology. As we can see in this picture provided here, Six Sigma MEC improvement process. So as we can see, define the project goals for the D, M for measure the process to determine current performance and quantify the problem, F, or analyze and determine the root cause of the defects. I, improve the process by eliminating defects. And C, control future process of performance to improve process doesn't degrade. So here is the research methodology. Here is the flow. As we can see here, at the left, plan, analyze, modeling, result, and application. But let us focus on this flow chart. So in this project, the literature review is done first based on previous study. So and then the problem identification, set research objective, data collection, data analysis, 3D modeling animation, augmented reality scripting for functionality. And this area, 3D modeling is done in Blender, and augmented reality scripting is done in Unity Hub software. So as we can see here, augmented reality scene review. If want to add more model, we have to remodel back here. And if no, if the process is done, we want to stop there, so we proceed with the AR application making and installation. So as we can see on the right here, objective 1, objective 2, and objective 3. The objective 1 is achieved in the earlier process. Meanwhile, the objective 2 is achieved in the modeling and result area, which is to simulate the smart automatic handling system layout. And for the last objective is achieved in the last process, which is to provide SOP of making AR application in Unity Hub. So as for the literature review, as we can see here, handling system, material handling refers to the process of storing, packing, and moving subsistence in many forms. In most production systems, the material handling system is crucial since it is responsible for deliver the necessary material at correct time and in correct location. AGVs, unmanned vehicle that transport unit cargoes, whether heavy or light, from one area to another, said by Albert Tenuel, Monella, and Ravigan. And as for the literature review for the smart automatic handling system, in this study, the meaning of smart automatic is the application of hydraulic, machine, and robotic usage. Involvement of human in handling work is reduced due to usage of robotic aid, said by Ni AYC, Ong SK, and Chrysolorus G, and Motzis D. A well-designed automation system in material handling system would minimize the operator's mental workload, increase productivity, which contribute to improving situation awareness and enhancing material handling flexibility, said NYC AYC, Ong SK, Chrysolorus G, and Motzis D. Let us proceed to the example of a 3D model built in Blender. So here is the example. This example of 3D model developed and exported into Unity Hub. It will then displayed on phone screen and overlaid to real environment. So this is the example of picture as tracker. So as for the tracker, take picture of the handling system components using smartphone camera or whatever, as long as the format is saved in PNG or JPEG and imported into Unity Hub. This is due to Unity Hub software only recognize this picture format. So here is the example. So this is phases of making our application. As we can see here, Open the Unity Hub software and choose the image target, which is used as tracker to pop up the 2D model or 3D model when the smartphone camera pointed on it. Second is import the 3D model or 2D model which created in Blender software into Unity Hub at same section with the image target. And the third step is the model can be rescaled in the transform section. For the smartphone phase, from download and install the APK file in smartphone, open the application and it will directly enter the camera mode, pointing the camera into tracker or image target. And the fourth is the 3D model or 2D model that been imported will pop up automatically on smartphone screen once the camera detect the tracker. So here is the overview of Smart Automatic Handling System in SMRI lab in your ITM. As we can see here is the system where I will apply the AR. So firstly I have to study the mechanism and component first, then proceed to the next step, which is merging the AR with the system. So here is the components and the details. This is the station 1 of the handling system in this case study. Listed is the parts and its function in station 1. So as we can see here, from the feeder, double acting cylinder, photo sensor, inductive sensor, capacitive sensor, rodless cylinder, pressure switch, 5x3 wave valve, 5x2 wave valve, limit switch, PLC, which stand for programmable logic control, and the last one is air compressor. For the station 2, here is the parts and function, which is double acting cylinder, rodless cylinder, rotary actuator, vacuum generator, vacuum switch, photo sensor, inductive sensor, and last one is capacitive sensor. And here is the flow chart of sorting and storing, which is the process happening in station 1 of the handling system. From the switch on the power, insert the material in the feeder, taking 3 seconds for the sensor to detect the material present before the material push. After the material is pushed, the material will be detected by 3 sensors. Here is the crucial part because type of material will be determined by the sensor. What material detected? If the material is white, will be stored in slot 1. If black, stored in slot 2. And if iron, stored in slot 3. After the storing finish, after the material stored in the rodless cylinder stored, the rodless cylinder return to home position and end of. As for the station 2, which is pick and place process involved, so here is the flow chart. From switch on the power, double acting cylinder extend and suck the material. Next, the first level of slot or storage material is sucked by vacuum generator. As we can see here, material selection depends on programming. Double acting cylinder will retract. Rodless cylinder will going up while sucking the material. Rodless cylinder then will rotate 90 degrees and release the material into feeder. Lastly, the rodless cylinder will return to home positions, which is its initial positions. And after that, complete one cycle.